Recall that in order to use permutations and combinations, you're trying to arrange a certain number of objects out of a total. So the way I always like to think about it is you have a pool of items, and you have item 1, item 2, item 3, item 4, item 5, item 6. And out of those items, you're wondering how many different ways can I draw from those 6 items, let's say 2. So if I were to pick out 2 items out of here, then what would I be doing? Well, I'd be taking out of 6 items, I would be, well, either choosing 2 items, or I would, out of 6 items, be permuting 2 items. How do I decide which one's which? Well, I would want to use combinations if I didn't care about the order in which I had drawn them. So let's just say if I had drawn 2, 3, so I'm writing this as an ordered pair. If I drew 2 and then I drew 3, that's the same, that's equivalent to 3, 2. Notice how we use the 3 horizontal lines to indicate equivalent, because they're not really equal ordered pairs, but they're expressing the same idea. So we wouldn't care about the difference between these. However, if I did 2, 3, and 3, 2, they would not be equivalent under a permutation, because we would be saying, for example, that John wins a TV and Bob wins an Escalade, versus Bob wins the Escalade and John wins the TV. That's obviously a much different situation, and we do care about that order. Anytime we're dealing with any arrangements, arranging things, selecting items, and we have a fixed number of items possible. That's really important. So we would say fixed or finite, meaning that it's not infinite. We know how many things there are, and from those we're going to be selecting some. So for example, in the United States, in the world, there isn't an exact known stated population at any one point in time, so it probably wouldn't be permissible to use a permutation or combination unless you were just trying to get a rough estimate of some type of factor figure.